In this lecture, we're going to explore how inheritance and polymorphism play out with static members that we have in our classes. And we're going to be using this inheritance hierarchy here. Our base class is going to be shape. We're going to inherit from that and create an ellipse class. Let's look at some code here. So we're going to set up our base class as shape, as we said. And we're going to have one member variable, which is going to be our description here. We're going to have a constructor and a destructor. And we're going to have a default constructor, which is really not important here. But notice that we have a static member, which is called mCount. And if you remember, a static member variable is a kind of variable which is associated with the type itself. It's not associated with any object that you create. If you forgot this, please go back to our chapter on classes or user-defined types. You're going to learn all about static variables. Here we are just exploring how they play out with inheritance and polymorphism. Now, we have a shape class. If we inherit from it and create an ellipse class, for example, we're going to have all the data that was public in our base class to be public in this class as well. So by that logic, we are also going to get this static variable inherited, and we're going to be able to access it from ellipse objects. Let's try and use this in code here to really drive the point home. Here we are creating a bunch of shape objects. Here is our first shape. We print our static variable through this syntax here because it is public. We can do this. We're going to get a 1 because we just have one shape here. We create a second shape and we print the count. We're going to get 2 because we just have 2 shapes in here. We create our third shape and we try and print the count. We're going to get 3. And if you wonder how we are incrementing this static variable, we may do this in our constructor. We're going to see how this works exactly once we hit Visual Studio Code in a minute. But note that every time we create an object, we're going to be incrementing our static variable. That's why we see 1, 2, 3 as we create these objects here. This is the logic. Now, we have 3 shapes here. We go down and create a new object, which is of ellipse type. If we print the shape count, we're going to get 4 because an ellipse is a shape. And ellipse is inheriting the static variable from shape. So we're going to get a 4 printed out here. But if we also print ellipse count, we're going to get a 4, even if we really just have one ellipse. So the static variable from shape is being inherited and used in our ellipse class, and this may not be what we want. So the problem here is that the static variable we are using in shape and ellipse are the same because the one we have in ellipse was inherited from shape. That's why we have these results here. But sometimes we just want to have ellipse count to be 1 here because in reality we really have one ellipse. So how do we do that? To get that behavior, you can also set up another static variable named exactly the same way at the ellipse level, and you can do that like this. You can also override the getCount method to return the current count in ellipse. This is going to work through polymorphism because the getCount method is a virtual function. If you call this method through a base pointer, you will get the correct one called, which is going to be the most specific one through polymorphism. But what we want to see is how things are going to work now that we have a static variable, which is named exactly the same as the one we have in our base class here. The one in shape is exactly named mCount. It is a static variable of type int. The one we have in ellipse is also the same. It is a static variable called mCount of type int. But now ellipse is going to maintain its own static variable and shape is going to maintain its own static variable. Now we are going to get this kind of behavior. We are going to see that if we try and print the count of shapes we have, we're going to get a 4 here. But now if we try and print the count from ellipse, we're going to get a 1 because we really have one ellipse. And this is working because ellipse is going to maintain its own static variable, and this is going to give you this behavior if it is what we are after in our C++ program. Now we can also go on and create a bunch of other objects here. We are going to store them in this array, which is going to be storing shared pointers to shape, and we're going to store in derived objects. This is the syntax we can use to do this. And at the moment we do this, we're going to get 6 shapes because in total we really have 6 shapes, But 3 of those shapes are going to be ellipses, and if we try to print the ellipse count, we're going to see that we have 3 ellipses in our C++ program, and this is going to do what we want. Another thing you could do is also do shape polymorphism and call the getCount method, and you're going to get the correct getCount method and print the most specific count. If we are calling that method on an ellipse object, for example, we're going to print 3. If we call that on a shape object, we're going to get 6, and that's the behavior we could achieve with polymorphism with static member variables, and I really want you to be aware of this. Now that you know this, we're going to head over to Visual Studio Code and play with this a little more. Here we are in our working folder. The current project is Inheritance and Polymorphism with Static Members. We're going to grab our template files and put them in place. And I am going to grab our classes from my drive and use these as the starting point. Again, if you don't want to type or create these classes, you can use the files provided in the resource section of this lecture. You can download them and use them directly without having to create them, because we are really interested in how static members behave with our inheritance hierarchy, which happens to be setting up polymorphism. This is what we want to learn about here. I am going to open this up in Visual Studio Code, and we're going to take a good look at our classes. The base class is going to be shape, which is what we have here. It's going to have a virtual method, which is getCount here, and we have a static member, which is of type int. I am going to change my parameter here to be stdStringView, because that's what we should do in modern C++. Let's look at the CPP file for this, and we're going to fix this a little bit. And we're going to hop over back to the header file and look at what we have. We have a virtual method, which is going to return this count here. It is a const method because it's really not going to modify. It's just going to return a copy of the count member variable we have here. And this is a static member variable. Notice that it is not in line. So we will need to define this in the CPP file somewhere, because this is a declaration. We need to put in a definition, which is what we have in our CPP file here, because we are doing things in the older C++ way. We are going to increment our count member variable in our constructor, and this is going to achieve the behavior we really want, to have the mCount member variable, which is static, incremented each time we create a shape object here. Let's go back and look at our destructor and make sure that it is virtual, because we have virtual functions in this class, and this is the setup we have. Let's look at ellipse, and we're going to take out this static member variable because we don't want to set it up as of now. We will enable it in a minute. Let's make sure we remove this. And let's remove this because I don't want this. And now we can try to create objects of our classes and see how these guys play out. We can also go in ellipse and make sure the constructor is taking stdString views where we are needing strings. We can do that and hop over to the CPP file and do that, stdString view. I think this is going to make Visual Studio Code happy by now. We can hop over to the main CPP file and clean it up a little bit. And we are going to include ellipse. And in our main function, we're going to create a bunch of objects. Let's close the left sidebar here because we don't really need that anymore. We're going to create a shape object and we're going to print the shape count. We expect to get a 1 because we just have one shape at this moment. We're going to create a second shape here, and if we print the count, we're going to get 2 because we have 2 shapes. This is what we expect. We create another shape, which is going to be shape 3 here. We print the count, we're going to get a 3, but the problem is going to come when we create an ellipse here. If we create an ellipse and print the count, we're going to get a 4 because we have 4 shapes in our C++ program. But if we print the ellipse count here, we expect to get a 1, but that's not what we're going to get. We're going to get a 4 because the mCount variable in ellipse is inherited from our shape class. So it is going to be the same thing we have in shape here, because if you go back, you're going to see that At this point, ellipse doesn't have a static variable m count of its own, so it's going to use the one it is inheriting from the shape class. This is the behavior we're going to get here, and I want you to be aware of this. If this is what you want, this is fine, but in most cases, you will want this to be different because you want very clear information about how many objects of each type you have created in your C++ program. If it is just shape, this is going to be really vague because you want to know if it is an ellipse, if it is a rectangle, if it is a triangle. This is not going to be super clear. So let's build and really show you the problem here. We're going to pass this through GCC, our favorite compiler. We can also bring up the left sidebar, no problem here. And we're going to bring up a terminal window or a PowerShell window, I can say. We're going to clear and run Rooster. You're going to see that the shape count is going to be 1, 2, 3, and we have a 5 here because we are also incrementing the m count variable in our derived class. So we are incrementing twice if we create an ellipse object. Let's show you this. In ellipse CPP, we are incrementing the m count member variable, but in the base class, we are also incrementing that. In the CPP file, that's what we have here. And notice that the derived class is also calling the base class through our initializer list here. So this is the behavior we have. We shouldn't be incrementing this because ellipse doesn't have its own static variable as of now. Now we're going to build and really solve this problem. Now you see the kinds of problems you can run into if you have a static variable that is named exactly the same way and you have an inheritance hierarchy. Really weird problems can pop up and you need to be aware of this. Let's build and see that the problem actually disappeared. Okay, the build is good. We can clear and run Rooster. We're going to see that now this is what we expect. 1, 2, 3, because we have 3 shapes created up to this point here. If we create an ellipse, that's going to be another shape. If we get the shape count, we're going to get a 4. But ellipse count is also giving us a 4 because ellipse doesn't have its own static variable. To solve this problem, we can go to ellipse and set up our own member variable at the ellipse level. So we can enable this and uncomment it. We're going to go to the CPP file and make sure we are incrementing to get the correct count incremented here. I think this is all we need to do. We are also going to initialize the static variable we have at the ellipse level. This is going to do what we want and we can build again. Now we're going to get the behavior we want because at this point we are going to print a 1 for the ellipse count, and this really makes sense because we have 1 ellipse even if we have 4 shapes in total. So this is the design I think makes more sense in our C++ program here. We are going to build this again and pass this through GCC. The build is going to be good. We can clear and run Rooster. Now we're going to see that we have 4 shapes and 1 ellipse. This is what we want. Now that we have this, we can really do all kinds of crazy things. Hopefully you can see that the static variable is working exactly as we want. We can print the ellipse count, we can print the shape count if that's what we want in our C++ program. But we can also do shape polymorphism and get the correct getCount method called in our C++ program. For example, if we call the getCount method on a base pointer that is managing a shape, we're going to get this one called. If we have a base pointer that is managing an ellipse, we're going to get this one called. This is going to be super cool. Let's go up in our program and set this up. We're going to do this on the fly. Let's say shape polymorphism, and we're going to say shape pointer, and it is going to be an array. Let's say shapes. This is going to do, and it is going to be just an array. And we're going to initialize this and store in a bunch of objects. Let's put in our closing brace here. Let's go up and see what we have. For example, we have shape 1 and ellipse 1. We can use these. We're going to put in the address of shape 1 and we're going to put in the address of ellipse 1. This is going to do. And we can loop through these guys and call the getCount method. So let's do this. We're going to say for auto s, and let's do a reference because we don't want copies. And we're going to say in shapes, and we're going to call the getCount method. We're going to say s and say getCount. This is going to give us the count, and we can print this out if we want. We can say stdc out and count, and we're going to put a new line character here to separate these guys, and we can put a separator here, we can copy what we just used in our C++ program here, just to make sure this is super clear when we print things on the terminal here. We're going to build our program and see if it actually works. The build is going to be good. We can clear and run rooster. We're going to see that the count is going to be 4 for the first iteration because we're going to be calling the getCount method from shape because that's our base pointer. So this is what we're going to get. We're going to print the mCount member variable from the base class. That's why we have a 4. But on the second iteration, the object is ellipse, and we are using polymorphism because we are going through a base pointer, and this base pointer happens to support the virtual method getCount. We will get the most specific one called on the current object that our base pointer is managing here, and this happens to be an ellipse. So we're going to call the ellipse version of our virtual function here, and we will get a 1 because we really have one ellipse in our C++ program. This is what we see here. This is really all I wanted you to see in this lecture, how you can use static member variables with inheritance and polymorphism. And you need to be aware of these little things that can really be confusing, especially for beginners. We are going to stop here in this lecture. In the next one, we're going to learn about the final specification we can use in our inheritance hierarchy. Go ahead and finish up here and meet me there. Go ahead and finish up here and meet me there.